Welcome to Understand the Math. In this video, I'm going to teach you how to evaluate expressions with inverse sine functions. We'll first evaluate sine of inverse sine of root 3 over 2. We'll remind ourselves that the domain of inverse sine of x is x ranging from -1 to 1. X is equal to root 3 over 2, and this is in our domain. Because of this, our cancellation equation can be used, and we can say that sine of inverse sine of root 3 over 2 is equal to root 3 over 2. For our second example, we're going to evaluate sine of inverse sine of 2. Again, our domain for inverse sine is for x ranging from -1 to 1. X in this case is equal to 2, and that is not in the domain. So because of this, we say that sine of inverse sine of 2 is undefined. In our next example, we'll evaluate arcsin of sine of 30 degrees. The domain of sine x is going to be when x ranges between -pi/2 and pi/2. 30 degrees is equal to pi/6, and that is in the domain. We can then use our cancellation equation and say that arcsin of sine of 30 degrees is equal to 30 degrees. Our fourth problem is to evaluate arcsin of sine of 3pi/4. Let's again write down the domain for sine. That is between -pi/2 and pi/2. X is equal to 3pi/4, and that is not in the domain. So what we have to do is find an equivalent angle to 3pi/4 that is in the domain of sine x. The first thing to do is to plot our angle, which I've already done here in purple. Our angle is 3pi/4. Since the domain of sine x is between -pi/2 and pi/2, our angle needs to be in the first or fourth quadrant. Sine is related to our y value, and our y value for this point is positive. So that means our equivalent angle must be in the first quadrant where y is also positive. We can think of the angle 3pi/4 as pi/2 plus pi/4. So our equivalent angle in the first quadrant is pi/2 minus pi/4, which is pi/4. We can then write that arcsin of sine 3pi/4 is arcsin of sine of pi/4, which is in our domain, so this is just equal to pi/4.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.